GM features are manufacturing tools that are used to create components that are identical. These wood holding and tool guide devices are intended for part machining and assembly. A fundamental understanding of GM features construction is required to get the most out of them. Jigs and fitting can be identified in one of two ways: by the machine they are associated with or by their basic structure. As you can see, this is our organization chart. The group leader is Syed Azhar bin Syed Abu Tahir, following the member group which is Lin Tianmi, Kamaruddin bin Kamarul Zaman, and last but not least is me, Nur Amira Zulaika binti Muhammad Sufian.
Now, come to our product part and parts features. A connecting rod as automotive components is chosen as our part for jig fixture design. A connecting rod is an engine component that transfers motion from the piston to the crankshaft by acting as a lever arm. The connecting rod is responsible for transmitting the piston compressive and tensile forces. It permits pivoting on the piston end and rotations on the shaft end. It is most common found in an internal combustion engine. Steel alloys, aluminium, and titanium are some of the most popular materials used in connecting rods. Connecting rods are typically made of forged steel. It is widely used because it has high tensile and compressive strength. Next, jig or feature selections. Jig or features hence features. We choose features as our design. A feature is a work holding or support device used in the manufacturing industry. Features are used to securely positions placed in the certain locations or orientations and support work, guaranteeing that all parts produced with the features are interchangeable and complete with specifications. The features will hold the part securely while vibrations, cutting forces, centrifugal forces, and gravity add to dislodge the part. There are two features we are used to hold and produce the part. First feature is the part is clamping with locators and also custom workpiece holder with locator. Clamping prevents the part from shifting or being pulled from the fixture during the machining operations. The second feature is the workpiece is placed in the custom workpiece holder with single locator. A holder must position or locate a workpiece in defined relations to the cutting tool. The holder will then present the workpiece to the cutting tool in the required process. It must withstand holding and cutting forces while maintaining a precise locations.
Hi, my name is Syed Azhar and I will be presenting on the 3D model and bill of materials section of this assignment. There are two fixtures that will be discussed in this section. Both play a role in the process of machining our workpiece into the desired finished part.
Hello, my name is Kamaruddin and I'm going to talk about the calculation. For this calculation, we're going to assume that machining time for part equals 0.0426 hours, time for loading the part equals 0.0032 hours, and time for unloading the part equals 0.0024 hours. We will use the formula number of parts per hour, PH equals to 1 divided by total single parts time, which is S. So 1 divided by 0.0426 plus 0.0032 plus 0.0024. Therefore, the answer is 20.747 parts per hour, which we can conclude by which the answer is concluded to 21 parts per hour. Therefore, the fixture produces 21 parts per hour. Next, we're going to assume that lot size L, which is LS, equals 2,500 parts, and machine operator earning W, which is W equals 20 ringgit per hour. We will use the formula labor expense L equals to lot size and S divided by parts per hour, H multiplied with wage, which is W, so that 2,500 divided by 21 multiplied with 20. Therefore, the answer will be 2,385 labor expenses. Therefore, the cost required for labor expenses is 2,380.95 cents. After that, we will assume that two costs, which is TC equals RM 150, cost of labor, which is L equals 2,380.95 cents, and lot size which is LS equals 2000 parts. We will use the formula cost per part, CP equals to 2 cost, TC plus cost of labor, L divided by lot size, LS, so 150 plus 2380 and 95 divided by 2500, so the answer will be RM 1.01 per part. Therefore, the cost per part for milling operation is RM 1.01. For calculating tool saving, we will assume the total cost, which is TC, is 150 ringgit, lot size 2500 parts, cost per parts where the fixture is used, CP2 1.01, and cost per part without use fixture, CP1 equals 1.50 ringgit. We will use the formula total saving TS equals to lot size, LS will multiply CP1, which is subtracting CP2, and the total will be minus 50C. So 2500 will multiply with the answers of subtraction from CP1 and CP2, which is RM 1.50 and minus 100 and RM 150 minus RM 1.01, and then minus 150 ringgit RM 1225 minus RM 150. So the answer is RM 1075 total saving. Therefore, total saving is RM 1075. Lastly, for calculating the break-even point, we will assume that tool cost TC equals RM 150. Cost per parts where the fixture is used, CP2 is equals RM 1.01, and cost per parts without use fixture, CP1 equals RM 1.50. We will use the formula break-even point, BEP equals to tool cost TC divided by CP1 minus CP2. So 150 ringgit divided by 1 ringgit 50 cents, subtracting 1 ringgit and 1 cent, so the answer will be 306.12 cents, which can be concluded to 307 parts needed to TP break even. Therefore, the parts needed to break even points is 307 parts.